Hey everyone, it's Brian here. So today I want to do something pretty interesting. When I went to Hofstra University and was getting my master's degree, I had this great professor, and her name was Sharon Witten. And the first day of class, she provided us with this sheet of questions that every math teacher needs to be able to answer. So she gave us a bunch of them here. Now there's three I want to go through, and here are the three listed. The first one is, why must we define 0 factorial as equal to 1? Why is it true that x to the 0 equals 1 when x does not equal 0? And the third one I'm going to go through today is, why is a negative number multiplied by a negative number equal to a positive number? Now, if you would like to try any of these out right now for yourself and see if you can come up with the answer, why don't you pause the video now? Alright, hopefully you gave it a shot. We're going to go through some of these right now and see what the answers would be. So the first one here, why must we define 0 factorial equal to 1? Well, let's start off with some basic facts about what we know about factorials. I know that 3 factorial is equal to 3 times 2 times 1. Just like I know 2 factorial is equal to 2 times 1. Just like we know 1 factorial is equal to 1. Well, by looking at this here, I can come up with another relationship on how to do factorials. I can also say that 3 factorial is the same thing as taking the number 3 and multiplying it by 2 factorial. Well, if we look over here, we said 3 times 2 times 1, that can give us 6. 2 times 1 gives us 2, and 1 would just be 1 here. So if I took 3 times 2 factorial, well, that would simply be 3 times 2 factorial, we said was 2, times 2, which is 6. So that's the same answer here. Using this logic, we can come up with a basic formula. We can say then that n factorial is going to be the same thing as taking n and multiplying it by n minus 1 factorial. So how does this help us with 0 factorial? Well, let's use this definition to create 0 factorial. And the way I'm going to do this is by putting in n is 1. So if I substitute in n is 1 here, we get 1 factorial is equal to 1 times 1 minus 1 factorial. So we get 1 factorial is equal to 1 times 0 factorial in this case. Well, we know that 1 factorial is equal to 1. So the only way we can get 1 here is 1 times 1, which means that 0 factorial must be equal to 1. Alright, let's take a look at the second question here. So the second question was, why is it true that x to the 0 equals 1 where x does not equal 0? Okay, well there's a few things we want to realize to be true here. We want to make sure we know our exponent rules and some rules about division. So let's start with some exponent rules. If we had, let's look at an example here, x to the 6th over x to the 4. Well, the rules of division tell us that when we have common bases and we're dividing, we can simply subtract our exponents and leave our base. So we're going to leave the base of x here, and then we're going to subtract our exponents, 6 minus 4, which gives us x squared. You also want to know that anything divided by itself is equal to 1. So if we had like the number 5 divided by 5, that would equal 1 here. Okay. So continuing on then, what if I said x to the 3rd over x to the 3rd in this case? Well, if I look and use this rule here for exponents, I simply subtract the exponents and leave the base. So the base stays x, and then it would be 3 minus 3, which we get as x to the 0. Okay, but we also said that anything divided by itself is equal to 1, and surely x to the 3rd divided by x to the 3rd is the same thing as 1. So this means then that x to the 0 must also be 1. finally, we want to know why a negative number times a negative number is equal to a positive number. Now, you can go ahead and prove this out, but I assume most people watching this aren't studying to be math teachers, so we're going to look at this with some real examples here. So let's say I'm going to use 2 times negative 4 in this case. Let's start with a positive number times a negative number and show that that has to be a negative number. Well, we know that 2 times 4 plus negative 4 would equal what? Well, we know that 4 plus negative 4 is equal to 0. And simply 2 times 0 would have to be 0. So I know this whole statement here must be 0. All right, I'm going to go ahead and get rid of that. Now we also know that we're assuming that all the field properties are true here, that a times 0 equals 0, that you can distribute things. So let's say I were to distribute this. If I distributed this, I would simply get 2 times 4, and then I would get plus 2 times negative 4. And we know that this has to be 0. Well, we know that 2 times 4 is equal to 8. We know this whole thing has to be 0. So then I have to know that 2 times negative 4, the only way I could get 0 here is if it was equal to negative 8. 8 plus negative 8 would be 0. So I've just shown now that 2 times negative 4 is negative 8. So a positive times a negative is going to give us a negative number. All right, well now what about a negative times a negative? How do we know if that's positive? Well, we're going to do something very similar to this here. So in this case, let's say we looked at negative 2 times negative 4. And I want to see, does that really equal a positive? Well, I can rewrite this as negative 2 and then 4. I'm sorry, not rewrite. Let's just say we wrote out this again. Instead of just 2 times 4 plus negative 4, this time we're going to do negative 2 times 4 plus 4. Now again, same concept here. We know that this equals 0. So I'm going to hold true, again, the laws of distribution, and I'm going to distribute this out. So we'll get negative 2 times 4 plus negative 2 times negative 4. And again, I know this equals 0. Well, I just showed that 2 times negative 4 was negative 8. I just showed that. This is negative 8. Plus, whatever this comes out to be, has to be 0. Well, again, in this case, in order to be able to answer that, negative 8 plus blank has to equal 0. Well, the only way we can get that equal to 0 is if this is a positive number 8. So a negative times a negative has to be a positive. Now this is just an example showing this. This is not a proof. So if you wanted to actually go through and prove it, you could try out with A and B or any kind of variables that you would like. All right, but I wanted to show you a real example here because I think that will be more helpful for a lot of you watching this. Also, if you want to see the other questions that math teachers should be able to answer, there's some really great ones. I'm going to leave a link in the comment below where you can find them. All right, hope you enjoyed them. Let me know how you did with this and how many of you got correct.